first law states, an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force.
The reason our experiments demonstrate Newton's first law is that both the flashlight and the cup were initially at rest. Even after the forces were acted upon it, both of them stayed at rest, demonstrating Newton's first law.
Newton's second law of motion states the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force and inversely proportional to the mass of the object.
Newton's second law states that the summation of the forces is equal to mass times acceleration. As we added 20 kilograms onto the pre-existing box, we could see that it took Elliot more force to push the box across the room.
Newton's third law states that for every action there is an equal and opposite reaction, meaning that in every interaction there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object.
When the black car collides with the yellow car, we can see that both of them have the same force but in opposite directions. With that being said, we can see that the mass does not have any effect on the forces, as the black car is heavier than the yellow car, but still they have the same amount of force in opposite directions.